Okay, so here we go. This is the official start now. Those are the topics. Warm up. I'll put warm ups just so we get a couple in there. Keep our brains fresh. And then we'll do these today to keep our lives moving forward. We have like 2 topics left, maybe 3, until the end of the course, and then it'll be whatever review time we get there at the end. Okay, so a couple warm-ups first. Warm-up number 1. This is going to go way back in time. Find the factors of, we'll say, I'll put 3 of them down, or just 2 of them here. X squared plus X, Deanna, minus 30, and 2x squared plus x minus 15. So if you need to go back into your notes, go right ahead. If you need to consult your classmates, go right ahead. I'll give you a couple of minutes to think about. Yeah, the question from class, instead of x, there's a 1 in front. Doesn't replace it, but invisible 1 in front. Okay, that's 1x there. 1x there. It's true. Any other questions? What's the question? Find the factors, or can't read my writing? This is like a of with style. Zoom, any questions?
No.
No? Okay, then I'll pause the video for give you guys a chance to work on it. It should be 2x squared, not just 2x down there. But I'll update the video. Here's a reminder, when you're factoring, when you're finding factors, this is what you're looking for. The 2 sets of brackets that will multiply together to get you back to the original expressions.
The first one can be x and 6 and x and 5.
Yeah, Zoom got one of them. Zoom got the first one, or most of it. There's one part that I haven't heard yet.
X squared 2. I'm not sure.
No, everything you said was good, just missing one little fact.
Oh, minus the minus, right?
Yeah, exactly. Which one?
The minus 6 and minus 5.
Ah, so you got to check that.
Oh, no.
No, the 5 is minus and x is plus.
Good save. Yes.
Oh, okay. Yeah.
Okay. So I'll put the answers in. It's up to you for the first one. It's up for you to check it. We got x and we got x. And multiplies to minus 30. So we got 5 and 6. 5 and 6 multiply to 30 there. And
The second one is
One of them is 3 and one of them is -5.
Wow. I'm looking at the first one there, Parsa.
Okay.
So we got 5 and 6. One of them's positive and one of them's negative.
First one is
So
first
which,
one is positive and second one is negative.
yeah, the 5 is going to be negative and the
Mhm.
6 will be positive since -5 plus 6 gives +1. Remember that from before?
Yeah, yeah, I remember that.
Okay. So these are just the answers. I'll show the workings after. Does anyone have the second one here?
Yeah.
Parsa, what did you get?
Uh, 2x here.
2x, yeah.
Yeah.
X
And
there, that's true.
yeah. And -3 plus 5.
So Parsa says -3 and +5. Is that what you want?
Yeah.
Yeah,
Mm,
yeah.
those are the numbers, but I'm not sure where they go. You
I
can
think
always check.
-5
Yeah. I'm thinking I'm liking that answer instead. -5 there.
and 3 positive.
Nice. +3. Yeah. Okay, so these
So
answers are correct. Okay, so I'll show the workings on the next page for each of them. Warm up number 1. Yeah. Yeah. Get it from your friend there. Okay. So for A part, x squared plus x minus 30. What do we need? What do we got to do to solve this, to get these those two bracketed terms?
We need to multiply them
They
together.
need to they need to multiply to 30. And in fact, minus 30 is best.
Mm-hmm.
So we can start listing them. Which ones, which numbers can work? 3 and 10? Yep. That's possible. 5 and 6, those are the answers, right? So those ones are there for sure. What else? Yep. 2 and 15, 15 and 2. Yeah, we'll have our signs in there as well for sure. Any others? Yeah, says the teacher. 10 and 3 is there. Yeah, 1 and 30. So this is a bit all over the place, right? Try and go in order. 1 and 30, 2 and blah, blah, and then try along the way. 3 and 10. Organized, and when they start being close to one another, then they flip, then you're done. Okay, but yes, plus and minuses all the way along. Okay, pluses and minuses. Okay, so we also need numbers that these pair of numbers, they have to add up to the middle number, the invisible 1 that's there. So making it minus 30, minus 3 and plus 10, does that work? No, that gives plus 7 when you work out those. How about 2 and minus 15? Does that work? No. What does that give? Minus 13. Nice. Okay. Which one does work? The minus 5 and 6 like that. Okay. So officially what we do next is we use these numbers to replace this middle term. All right. So we got minus 5x and then plus 6x and then minus 30 like that. See, so the two numbers that work, the two numbers that add together and multiply, add together to give the middle and multiply the last number. Write them in there. Then it was a while ago now, but factoring by grouping, because we have 1, 2, 3, 4 terms there. So how does that work? You do GCF 2 terms at a time, right? These first two, then those two. Okay, so what's the GCF of x squared and minus 5x? X minus 5 isn't the GCF, but it's what's left over. Yeah, x is officially the GCF. Yeah. That's good. How about the next two terms? That's what we're looking at. Yeah. What's the GCF of those? 3 goes into both. That's true. But we want the biggest one. G for greatest. 4 doesn't divide 6. 2 divides both, but it's too small. There's bigger ones. 15 divides 30, but doesn't divide 6. No. 8 doesn't divide 6. And 8 doesn't divide 30 either. 8 divides 40. 12, the other way around. Yeah, 6 works. 6 divided by 6 is 1. 30 divided by 6 is 6, right? Okay. So plus 6 is the GCF. Then you got to figure out what's on the inside. Now here's the thing. If we multiply back in, we got to get back to this. So minus 5, because 6 times minus 5 is minus 30. And 6 times what gives you 6x? It is, yeah. What do you do to get the inside? Do you need a reminder how that works? We did something like this before. We had x squared minus 5x. So what divides into both? X.
X.
Yeah, thanks. They're a deal, right on time. And then you divide both by x to see what's left over.
X
So you get
small x
x minus 5. Yep. And so this is actually up in this part here. Skipped it just as a save some paper. So this x is this one right here. X minus 5 is what we're left with. That's that right there. Perfect. We do the same. We go 6x minus 30. So what divides into both? Oh, I see. If you're thinking that way from before, 2 divides both. What are you left with? Yeah. So not wrong what you said earlier, just not finished. Okay. Minus 30 divided by 2. Nice. 15. Okay. So can we keep going? Yes. Yeah. 3 only, actually. X minus, right. Okay, so the GCF comes from multiplying those together, which we do to get 6. And then the leftovers are on the inside. Okay, so as a reminder, this step, yeah, I probably should have done it first. That goes in there. You find the GCF, and then it creates this line here. Finish up. X minus 5 is in both.
X and 6.
Not x times 6. That'll be going backwards. We'll get 6x.
2 times 3, 6.
Oh, yeah. 2 times 3 to give the GCF of 6. That's correct. That's what we do. Yeah.
So it's plus or minus, I don't know, I'm not sure. 6 and x minus 5.
Not bad. Zoom is trying to decide, is this positive or negative? +2, +3, positive times positive, positive.
Negative. But positive.
Yeah, I'll take positive.
Thank you. Yeah, that's
Time zone math.
always have a problem with the minus and plus.
Yeah,
Thank you.
right. So that creates now the final result like that there.
Yeah.
Yeah. Okay, so we can do the same. So that gets the answer. If you wrote x plus 6 first and then x minus 5, that's fine. No, the order doesn't matter. That's okay. Any questions about that one? No? Okay. Same stylings, except for the order. For the next question, we'll do this first to get that line, okay? And as a reminder, that's the question there. Oh, that looks good on the screen. Oh no, got the answer there. So I'll do it on a separate page here. I'll just copy it down. That goes there. That goes there. Okay, so same challenge as before, fingers and toes. From class, they said two numbers that give minus 15. No, actually. When there's a number in front, what you do, you got to multiply it. Okay, so you need two numbers that gives officially minus 30, but yep. So that's kind of nice, eh? See, 2 in front. So you have to do this little multiplying first. 30. Okay, because you have to multiply it by the number in front there. All right, so we have what numbers multiply to give 30? Let's try it in order this time. Oh, you guys are all jumping all over the place. 1 and 30, I'm going to put first. You're right, but organized, right? 2 and 15, yeah. $10, yeah. Okay, and? 5. Yeah. Okay, and then our pluses and minuses in there as well, okay? So we got to watch those. What do we do with these numbers? Right, add them to get the number in the middle, which is invisible. Now it's not. 1, that's a 1, even though it might not look like it. So what numbers are they? Oh, funny enough, same ones as before. That's right. Okay, so let's just check before we go into the next step. Minus 5 times 6, minus 30. Sign as well. It's true. And then minus 5 plus 6. Yeah, actually, this is what you can check. Some people like this style. Thanks. So let's keep it +1 so we don't change the question. No, it should be plus. I made a mistake. +1, straight up right there. Okay, number in front. And you're saying minus 5 and 6. I think you're right, but let's check. Negative times a positive is negative. Yes. 5 times 6, 30. So that one works. minus 5 plus 6 plus 1. Yeah, those are them. Okay, so what do we do with these two numbers now that we found them? They don't automatically go to the answer this time. Well, they didn't last time either. What do we do with those two numbers? Instead of 1, yeah. No, we use these two numbers that we find. So instead of 1, we're going to use the minus 5. Yeah. Nice. Plus 6x. Yep. And then the minus 15, we just carry it down. That's there at the end. Equal sign, if you can squeeze it in there. So it's professional looking. Okay. No number, true for the GCF. How about letters? All right. So I'm going to do it properly like we did when we first went through this. Okay, the GCF, you set it up like this. 2x squared minus 5x. So what goes into both? Any numbers? No. Letters? Yep. There's an x in both. Nice. So it gives 2x and minus 5. When you divide, okay, to get this result, divide. Okay. Those are the first two terms. The next ones. 6x minus 15. How about both? From class we said 3 and 2. I'll take both. 3 first. What do we get? Yeah. Oh, wait. Did I say both? Okay, I'm gonna undo it. What the heck? Don't want to be telling you lies. I was thinking of the other question. Yeah, 3 only. 2 doesn't divide 15. That would have been a disaster if I put that. Okay, so 3 only. Good. Okay, and nothing else. So what can we write? Yeah, x bracket, and then 2x minus 5. Nice, those come down like that. And then I think we can finish this up with what we get here at the end. Mr. Peter, want to finish it off? Yep. Oh, minus 5, yeah. Yeah. X plus 3, that finishes it off. Good. Nicely done. Right on, one of those. Okay, any questions from that? No, no, thank you. Do you remember it now? Yeah, 100%? Okay, we'll find out. Not right now, though. Yeah, on the test when it comes up. Okay, one more warm-up question, then we'll get on with our lives. Smaller one, though. We've done so much good stuff this year, huh? Warm-up number 2. Find the sum of arithmetic sequence. Given by minus 5, 7, 19, um, 139. So I'll pause the video. To give you a moment to think about this. Okay, so here we go. Solution. We got to find the sum. Okay, so notice what I think is a good idea to do if you see an important math word like this, then give it a little underline and make sure that you understand what they're asking for. If they want the sum, that means it's going to be Sn, right? Okay, that's a good little trick. Now then, if we're looking for Sn, yeah, we got both of those formulas there. The first term, the one that has the first term and the last term, or the one with 2a1 in there. Okay, just because we have the last term, I'll use that one instead. So that one's going to be a1 plus an. We can make our list as well from the info that we have. We should probably do this first, actually, before selecting the formula. That's a bit out of order. Okay, so a1 is going to equal how much? Minus 5. That's clear from the work on the board and good. We got an, 139. With the little side calculation, what do we get for D? Yeah, 12 it is. I'm going to go easy on my brain and go 19 minus 7. So D will equal 12. And, well, take a look. What's missing? N. We don't know that. And we're looking for the sum. So we have everything at least in front of us here that we know and that we can use, okay? So in order to get the sum, we got a1. A1 is going to be minus 5. We got an, that's 139. But we get stuck here. We don't know what n is, right? So that means we have to do a little side work to figure out what n is in order to finish up the question. Okay, so how can we do that? Well, we can use our other formula we got, our an type formula. Because we know what that term is. We know the first one. Okay. So since we don't know what n is, we can use this. An is equal to a1 plus n minus 1 times d. So our last term is 139. Our first term is a minus 5. N is what we need. And d, we figured out, is 12. Okay, so now we can do the algebra. Look at this. We can figure out what n is going to be. And then we can use it back in our earlier equation right here. Okay, so let's multiply that through in our usual way. Minus 5 plus 12n minus 12. And this will give 139 is 12n minus 17. So just doing algebra, right? Solving for n now. Let's get the 17 out of the way. So move it to the other side. (12n). 139 plus 17 is how much? Yeah, good. It's 156. That equals 12n. And so when you work this out, when you divide both sides by 12, n will equal 13. So with n being 13, we can now go back to our sum equation here, series equation, and we can put it in place. Nothing but numbers. We can work it out then. Okay, so putting that in there, we now have Sn is going to equal 13 is now in there. Minus 5 plus 1, 39 like that. Ah, yeah, good. I mentioned this yesterday. Once you start substituting things in, then it should change along the way. So yeah, good. It's no longer Sn. It was, but now it should be S13 because we replaced n with 13 there. A plus. See? Just like I promised. On the inside, what do we get? 144 or 134? Yep. 134. Now a little bit of number crunching. So you can break out your old calculatrice if you like for this. It will be, yeah. You can do, I was going to say you can do this all on your calculator at once. But if you like, you can think of this as, actually put it underneath, 6.5 if you like, times 134. Grand finale gives an answer of what? Oh, S13 is equal to? We had it earlier from someone. 871, right? Yeah. Okay, good. So that finishes that. A plus AN is what it is. Yeah, can go back here. Question is when to use the other formula. We have our first term, which is A1, which is minus A1 minus 5. And we happen to have our last one, 139. You can actually, yeah. You can use the other one and it'll work as well. I could even do a little quick demo here. As long as you keep track of all the numbers that we know. If you want to use this one instead to get the sum, you still have to find n, right? So that part doesn't change. But if you use this one instead, Do we have A1? Yeah. What is A1? No, A1. First term. I got it. How about you? What's the first term? Yeah, -5. What's D? Okay, so let's just check these off. We got -5, so that means we got that one. D, yeah, we did our side calculation. You can do that before. We got D. And I'm going to say from A n blah, blah, blah. Therefore, we get n is equal to 13. So we don't have n directly, but we do a n is equal to a1 plus n minus 1 times d. So we get n is 13. So we have a value for n now as well. A value for n, value for n. Nothing but numbers. Okay, so we can substitute it in here and it'll still work out for you. You all right with that? Yeah, just finding n will be a little bit of side work. This is day 38, I think. Or at least that's what I'm calling it. Yeah. Okay. Let's get on to the new stuff today. What we're doing, get us ready for our new section here. Something called similar triangles. Okay, so what are these things? Well, importantly, similar triangles, what they are, here's a little example like this. You got a triangle like that, and then a little triangle that fits on the inside. I'm going to use some letters so it's kind of mathy like. You got A, B, C, D, and E. So the thing to notice is that the this angle down here is in both the small triangle and also the big triangle, right? Okay, so let's just get those noted first. We got our small triangle. That's ABE. And we have our big triangle. That's ACD. So the first thing I'm going to watch is the angles. And so notice angle A is in both of these triangles, right? It's in the small one, and it's also in the big one. So angle A is in both. Also notice angle B and angle C. Angle B, just with your eyeballs, you can see that angle B is going to equal to angle C. And then down here, angle E is equal to angle D. So what we have is two different triangles with the same angles, same size of angles. And that's what we can say similar triangles are. Okay, so similar triangles. What do they have? They have different, they are different sizes. But what they do have is the same angles, same size angles, that is. Now, what's sometimes helpful, these pictures can be, they can be kind of confusing with these two triangles in, on top of one another. Sometimes helpful to have them separate. So watch this. I'm going to put the small triangle here. Call that, that's the ABE. Then the bigger one I'll have right beside it. That's ABE, same letters as before. And this is ACD. So what do we got? We got different sizes. So for sure, AB and AC, those are different lengths, right? Even though they match with one another, right? Different lengths. BE, different lengths. And then AE, AD, different lengths. Just a math symbol for you to show the angles are the same. You would have an arc with one dash in there. That's an arc with one dash. So that shows that those sides are the, or those angles rather, are the actual same value. Over here, might have two dashes like that. That's another way. And then this looks like 90, so that's yet another way to show that the angles are the same as one another. Okay, now, does anybody know what a ratio is or a fraction?
It's like relation to one. Let's say here it's a triangle to another.
Yeah.
This one, for example, I think it's like smaller.
Hmm.
3 times, so it's 3 to 1.
Yeah, exactly. So from class, we said, just eyeballing it, this one's about 3 times as small as this one, right? And this one's 3 times bigger than that one. Okay, so what we can do is add to our list here of things that are the same as one another. The ratio of matching sides are equal. Okay, so what is this saying here? Well, I'm going to pretend that this side here is 3, that's a 4, and that's a 5. I'll say this is a 9, that's a 12, and this is a 15. Okay, so what I'm going to do, notice the green side here matches with the green side over there. And if it comes up, I'll say the, yeah, we'll use the black side. The bottom. That black side there matches with that black side there. True? True. You can see that from the pictures. And so what I want you to notice is how these ratios are the same as one another. If we look at the small triangle here and we go the line BE, which is the green one, divided by the line AE, we get the value of 4 divided by 3. If we look at the big triangle, what's the side that matches with BE? Well, that's the side CD, right? BE is there, CD is there. 12 over, we got to stay in the same triangle. Okay, so CD matches with BE. What matches with AE along the bottom? 3 for this. What about in this triangle? Yeah, 9 from AD, right? And so this will be 12 over 9. Now, with all fractions, what you do is you reduce them. So what number divides into both of those? Yeah, 3 goes into both. So 12 divided by 3, what does that give? 4. 9 divided by 3? Right. So this is the point where these are the same. Okay, these ratios of matching sides are the same. Okay, this works with the other sides as well. So let's just use the green ones and then the long side to show that same fact there. Okay, so for the small triangle, yeah, I think I can squeeze that on there. For the small triangle, we got side BE, and then we're going to divide that by the long side, which is AB. That one's off there, right? Okay. Okay, so how long is side BE? 4 indeed, right from the picture. How about side AB? 5. Okay, good. So we'll save that and see what we get for our big for the big triangle now. Yeah, BE, just like before, matches with CD. And What side matches with AB? AC, right? That long side matches with that long side. So AB and AC. I heard someone say 12, and yep, that's exactly it. CD. CD is 12. AC is how much? Yep, 15. Yeah. Yeah, just different order. You're right, though. So then, making this as small as possible, divide by 3. Yep, 3 goes into both. 4 over 5. So look at that. See? Those matching sides, or those ratios, they match one another again. Right? Okay, so this is fun. Because what this allows us to do is we can actually go out into real life and use this to solve some sort of problem just by making triangles. Yeah,
Can I go earlier today? Because it's so good.
sure. Got this for you. Both sides, if you don't mind. Okay, so this is the situation that we have here, and you can do this. Yeah, do this on your way home after school. If there is if today there is a sun shining down, nice set of sunglasses. Okay, shining down on our world. If this sun hits a tree that is there on the ground, what's going to happen? Grow? This is a tree, believe it or not. Yeah. Oh, yeah. Okay. Okay, just. Oh, come down? Fall? Not necessarily. Because trees they like the sunlight, right? The sun shines down here, the rays hit it. What you're going to get is a shadow along the ground, right? You walk outside, the tree is going to have a shadow on the ground here from the sunlight. And if you are out there as well, when the sun shines down, you will have a shadow on the ground as well. Okay, and so this is what you can do. You know how tall you are, right? I assume? Yeah? Okay. So I'm going to say 1.5 meters for your height. Okay. If you got a friend out there, they could measure how long your shadow is on the ground there. And let's say they do it and it's they get 0.8 meters for how long the shadow along the ground is. Okay. Well, notice, what did they give you? What did they tell you? What you got is a small triangle like this, where this side is 1.5 and this side is 0.8. Just by changing the picture to something a little more mathy, right? Well, let's say we want to figure out how high this tree is. Okay. If we measure this shadow, and let's say it's 6 meters. Then what we got is this situation. We got a bigger triangle where that's 6 along that side and missing value along that side. Well, remember, because these ratios are the same, we can connect these two triangles together. You see? This side here in green matches with this side here in green. This side along the bottom matches with this side here on the bottom. Okay, so we can create some fractions now where, just like we did, create some fractions, and we can figure out how tall this this tree here is. Okay, so let's get some sides matched up and create an equation here. This question mark, or these question marks, divide by 6 would be the same as 1.5 dividing by 0.8. And see how everything matches? That side, those go on the top. This side, that side, those go on the bottom. And this question here, if you don't like these two question marks, you can think of it as x divided by 6 is equal to 1.5 over 0.8. Okay, so by solving this equation, then we'll get these two question marks. We'll get the height of our tree that we don't know. Okay, so let's take a look at that. From matching the sides, and then creating the ratio, we can get this over 6 is equal to 1.5 over 0.8. And to update it, we'll say x for the height there. X over 6 is 1.5 over 8. 0.8. All right, good people. Let's work this out. What can we do? Well, we can work on the right-hand side. Yeah, from class they said do this. Yeah, you can, if you know that.
6 times 1 1 5, and then dividing by 0 and the 0.8.
Not bad. Yeah. So there's a couple of ways to do this. From class, I'll put it over here. You can go cross multiplying. You get 0.8x is equal to 1.5 over 6. That's one way to do it. Okay, so what's 1.5 divided by 6? See, get your calculator out for this one. Looking here, it's 1.5 on top of
It's
6,
zero
so it's
point
divide.
25. 0.25.
Oh, whoops. Yeah, thanks. Let's do it properly if we're going to do it. 0.8 gets multiplied up there. Yeah, so that goes to multiply. That's the point. 1.5 now times 6. So Parsi, you were right, but I gave you the wrong question. Let's do this instead. 6 times 1.5. That's better. Okay. So working it out like this. What's 6 times 1.5?
9.
9 it is. Yep. That's true. And so you can get a final answer for this one. What's that? Yeah, I should have it in there. It's a good idea. Otherwise, this ends up looking like a marker. It's not a decimal anymore. 1125 sounds, yeah. You can check. Okay, so this shows then by solving this, we figured out what x is. We figured out what those two question marks are. We figured out the height of this tree that we had, right? So that'd be 11.25 meters. Okay, now I think there is a slightly easier way to do it. So I'll do it off over here. Because you have calculators and such, you can just do this right-hand side right away. What's 1.5 divided by 0.8 just by looking at it there? Beep, 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 beep. X over 6 is equal to, what's 1.5 divided by 1 point something. I think it's more than that. Yeah, punch it all into your calculator and you get this side being 1.875. Okay, that divided by that. To get x by itself, where does the 6 go then? Multiplies over there. So x is now equal to 6 times 1.875. Yeah, you work this out. I'll do it officially. So my heart goes down. Yeah, we get the same to confirm there. 11.25 meters. Okay. Okay, so that's using similar triangles there. Now, so remember the sides have to match. I'm going to match the sides and then create the ratios, okay? So let's try a second one. Second example. Example 2. Let's see, you got something that looks like this. And that's the big one, and that's the small one. Okay, that to me looks like a 4, a 3, a 5. You know, numbers might be weird sometimes. So let's just say that this is 10. And we want to figure out what that side is going to be. Oh, I got it backwards. Clearly, this is the bigger triangle. That's a small one. Okay, we'll work with that though. What's that? This one here? Yeah, they don't give it to you for some reason. They're just being goofy. Good question. No, if you look here, that's the only symbol that's given. So we're only going to find this one. Okay. We could find that other one in the same way. Same process. Okay, but we'll just find this one here. Okay, so what sides are we gonna use in our in this triangle here? Or maybe a nicer question. What side matches with this side here? Clearly the 5, right? So I got some fancy color to use. So green and the green. One's on the bottom. Those ones are going to match, right? Okay. That looks good. So then, what is the equation going to look like? Five over 4. That looks good to me, taking that side with that side. And so since 5 is on the top, this is important. Since 5 is on the top, we need this matching side on the top. Okay. No, these sides are in the same triangle. So these sides will be from that triangle. Okay, so the 4 matches with what? 10, right? Okay, so 4 is on the bottom, 10 is on the bottom. What goes here? Someone said X, but I'll just keep it as that for the first step. 2 question marks like that. And then if you like, certainly you can update it so that there's an X in there. And so this equation here is now what we got to solve. So what do we do first? Sure, we can go 10 times 5. What do we get? Yeah. So 50 on the top over there, 4 there. The 10 is gone. 10's multiplied up with the 5 now. Nice. And so 50 divided by 4 now. What is that going to equal? That's 36. No. When it's on the top like this, 50 divided by 4. Yeah. Oh, you want me to check my work again? Let's see. 10's on the bottom. That goes over there, which is okay. So 10 times 5 is 50. And this stays down there. So yeah, it's divide. This is good. 12.5 will do it. Yeah. See? Weird numbers, not so easy to see is put the oh, this is a decimal. So yeah, we use decimal. Yeah, yeah. 50 over 4, no, definitely not, because that can be made a little bit smaller because 2 goes into both, right? So we can get 25 over 2. If you put that, that'd be okay because we can't get any smaller. This is so you could write it as a fraction, or you could write it as a decimal. Usually when you're talking meters and that sort of thing, you write it as a decimal, right? We just has more of a meaning because of our experience, right? You actually say it the other way around. It's 25 divided by 2. 12.5, yep. And this. That's the answer. Because if you go back to our to the question that we had, right? 3, 4, 5, 10, and what's this going to be? 12.5. Done, except for some homework. Now listen carefully. I don't want you hurting yourselves. With this first, we got there's 2 sides to it. Do the back side first. So numbers 3, 4, 5, 6. Okay, the front side we can't do yet. I ran out of time. So some things to show you. Okay. Yeah. So here you go. So I'm going to stop the video. Homework's coming around. I'll update Teams to make sure you don't do all of it. Okay, the second page only. 3, 4, 5, 6.